So we've been doing the H chart this past week, trying to write equations that are linear. This should look familiar. It's what we've been doing the past week. To get from 1 to 2, I have plus 1, 2 to 3, I have plus 1, from 10 to 15, plus 5, and notice how they're all the same, plus 5, plus 5, plus 5. But in a quadratic, so you have seen this before, but in a quadratic equation, it's not so constant. 2 to 5 is plus 3, 5 to 10 is plus 5, 7, 9, and you'll notice that these numbers are not the same. Over here they are. So we call this the first difference. The second difference is if we go from 3 to 5, that's plus 2. 5 to 7, that's plus 2. And then you start to see that these numbers are the same. This is what a linear graph looks like when the first difference is the same. I have a straight line because with every x I have the same change in the y. That's why it's a perfect line. In a quadratic, you'll notice that it doesn't make that perfect line anymore. It goes from here, jumps over there, kind of gets up there, and you'll notice that the slopes here are all different, right? Whereas a straight line, the slope is constant. That's why there's a second difference. Let's do some practice. Try to figure out if these are linear or quadratic. In order to do that, you need to figure out the first difference. On this first chart, the first difference, this is a plus 1, plus 1, plus 1. Over here it is minus 6, minus 10. Here it's minus, what is that? 14. And then over here I do a second difference to see if it's constant yet. So this is a minus 4, this is a minus 4. So we do have a first difference, and now we have a second difference where it's constant. So we know it's quadratic. So we'll put a Q over here for quadratic. I do it here. This is plus 3, plus 3, plus 3. So in this chart, we notice that this is a constant change, which means it is linear. Over here, we're going to do it 8 to 23, that is plus 15. This is plus 25. This is plus 35. That's the first difference. They're not all the same. So now we have to figure out the second difference. The second difference, to go from 15 to 25, that is 10. To go from 25 to 35, that is 10. So we notice that the second difference is 10, which means that this is quadratic. Okay? Let's try this one. 1, 2, 3, 4 is the left side. The right side goes minus 12. This goes minus 20. This goes minus 28. The second difference, because the first difference is not the same, we need to go to the second difference. That is a minus 8, and this is a minus 8. So there's a second difference, which means this is a quadratic equation. Now I go here, minus 2 to minus 5, that's minus 3. This is minus 3, and this is minus 3. My first difference is the same, so this is a linear equation. The quadratic rules, what is the xth value of the quadratic pattern? So we need to define the pattern. If I go from 2 to 8, that is a plus 6. 8 to 18, that's a plus 10. 18 to 32, that's a plus 14. Now that wasn't all the same. The first difference is not the same, so we do the second difference. 6 to 10, that's a plus 4. 10 to 14, that's a plus 4. We have a second difference. Now let's try to figure out this other term, this last one. So we do some math. Probably if I know that the second difference is a plus 4, then I know it's not going to be plus 14, it's going to be plus 18. So now I do 32 plus 18, which is 40, 50, 50. And this is the fifth term. That's to find the next one. So we need to figure out a pattern to, what if I wanted to do the 25th term, right? What if I wanted to do the 25th term? I should try to figure out a pattern that looks like this. I take the second difference, which is the 4, I divide that by 2, and I get 2, which means that I have the first term, which is 1, I multiply it times this number, which is 2, and I square this. 2 times 1 is 2, and 2 plus something gave me 2. Well, that something is 0. Now the equation, or the pattern that you'll start to notice once I keep going, is y equals ax squared plus c. So let's try that. If I have a, which is 2, my x, which is 2, squared, plus something gives me 8. Now 2 squared is 4, and 4 times 2 is 8. So 8 plus something gave me 8. Well, that should be a 0. So the pattern that they're looking for is y equals this, which is 2, x squared plus 0, which is nothing. This is the pattern that helps me figure out what could possibly be the 50th term. Let's try it again with these. If I want to figure out a pattern, I have to go figure out the second difference. Right here, this is plus 6, this is plus 10, this is plus 14. That's the first difference. The second difference is when I go from 6 to 10, that's plus 4, 10 to 14, that's plus 4. How do I find the pattern? I take the second difference, which is 4, I divide that by 2, and I get 2. So when I use this equation, I notice that a is 2. And now I need to figure out what this last c term is. So I go 1 times 2, actually I should go 2 times 1 squared, which is 2, plus something gave me 2. Well, that was a 0. This is the one we just did before. This is the pattern that I want. Let's try this one. This is plus 12. This is plus 20. And this is plus 28. That's the first difference. The second difference is when I go 12 to 20, that's plus 8. 20 to 28, that's plus 8. I take the second difference, which is 8, I divide it by 2, and I get 4. Now I say y equals ax squared plus c, where a is 4, x is squared, and we need to figure out what that last term is. So 4 times 1 squared is 4. 4 plus something gave me 4, which is 0. You can try this last one. Here's some more practice problems. We already did this one and this one. Let's try to do something like these blue ones. So I have negative 5 to negative 17. That is minus 12. This is minus 20. This is minus 28. That's the first difference. The second difference is if I go from 12 to 20, that's a minus 8. 20 to negative 28, that's a minus 8. So my second difference is negative 8. And I take negative 8, divide by 2, I get negative 4. So I have an equation that looks like y equals negative 4x squared plus something. Well, negative 4 times 1 squared is negative 4, plus something gave me negative 5. Well, that looks like a minus 1. So this is my equation. You can try the rest on your own. And here's some more practice problems.